Today we're going to talk about conic sections. And first of all, I want to tell you what a conic section is, where it comes from, and then we'll get into the notes and talk specifically about circles. So just take a look at the diagrams I have here. A conic section is a cross section of a cone. So as you can see in each diagram, there are two cones. One is opening upward and one is opening downward. This is called a conic. When you slice a conic in different directions, you form these things called conic sections. So the conic section we're talking about today is a circle, and that's formed when you slice horizontally across one of, this is called a nap, one of the naps of the conic section. After circles, we'll be studying parabolas. Parabolas are formed when you slice a conic on a diagonal. You can see a parabola, that cross section is formed. When you slice a conic on a diagonal through both sides of the cone, you form an ellipse. This cross section is an elliptical shape. When you slice down through both naps of a conic, you form, or the cross section that's formed is a hyperbola, kind of almost like a parabola here and a parabola here, although they aren't quite parabolas. Today we're going to focus on circles. And the official definition of a circle is a collection of all points that are equidistant from a fixed point. If you have used a compass before to draw a circle, that fixed point is where you place the anchor of the compass, and then the pencil draws all the points, traces over all the points that are the same distance from that fixed point. We're going to look at two different forms of equations. The first is a standard form, and the second is general form. These are forms that you'll have to memorize and be able to go back and forth between the two forms. H and K should be familiar to you. H is a horizontal translation, K is a vertical translation, just like it has been for functions that we've studied in the past, although a circle is not a function. HK represents the coordinates of the center of the circle. XY represent coordinates of any point on the circle. R is the radius, the distance from the center to any point on the circle. So in your standard form, it's really easy to see the center, and you can tell what the radius is by taking the square root of whatever number is here. General form comes like this. You have your x squared and y squared up front, then an x term, a y term, and a constant. General form is always equal to 0. We'll talk more about this form later. But let's start with standard form. We're going to write an equation in standard form of a circle with center 5, -3, so remember this is your HK, and a radius of root 5. So R is equal to root 5. All you have to do is put those numbers in the correct place. So it'll be x minus 5 squared plus y minus -3, which becomes plus squared, equals root 5 squared. Now keep in mind root 5 squared is 5, so go ahead and simplify that, write it as 5, and there's standard form. What I'd like you to try next is writing equations in standard form for all three of these circles. I'm going to number these. This will be circle 1, circle 2, circle 3. I encourage you to pause the video, write equations for all three, and then start the video again and see if you got it right. For the first circle, the center is 4, 9, x minus 4 squared plus y minus 9 squared equals, and now you have to find the radius. So the radius would be the distance from the center. I'm going to draw the radius this way because I know that if this coordinate point is 4 units from the y-axis, that's the x-coordinate, then the radius is 4. So remember, don't write 4 squared, write 16. Radius is 4. Circle number 2. The center of this circle is 4, 0. X minus 4. Y minus 0. You could write y minus 0. I'm just going to write y squared. And now the radius. So I know that this is at 4. This point is at 11. So the radius will be 7. Please don't write 7 squared. Go ahead and multiply that out and write 49. The third circle, the center is negative 5, negative 5. And the radius, so the distance from the center to either the y-axis, or to the x-axis is 5. Radius is 5. Please multiply that out and write equals 25. There's one other thing I want to talk about while we have this diagram here. It's this idea of a circle being tangent to the x or y axis. Circle number 1 is tangent to the y-axis. Tangent to means it intersects the y-axis at one point, even though the diagram looks like it overlaps. It intersects at one point such that the radius is perpendicular to the y-axis. Circle number 3 is tangent to both the x and the y-axis. So here, the radius intersects the x-axis at one point, and it's perpendicular at that point. Circle number 3 is tangent to the y-axis. It intersects the y-axis at one point, where the radius is perpendicular to the y-axis. This is going to come up a little bit later. So kind of keep that idea in the back of your mind, what tangent to means. Number 3, we're going to write an equation of another circle in standard form, and we're going to sketch it. So you'll need to kind of sketch out a little xy axis over here. And then we're going to calculate the x and y intercepts. So remember, we have h, k, squared. Radius is 3, so when I put that into my equation, 3 squared is 9. All right, if I want to sketch this, 2, negative 4 will be here. Radius of 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, it looks to me like, there we go. There are not going to be any x-intercepts because the radius is 3. We're not going to intersect the x-axis. So I'm just going to make myself a note. No x-intercepts. But I can calculate the y-intercepts because it looks like I have 2 of them, one here and one here. When you calculate a y-intercept, you let x equal 0. So I'll substitute 0 in for x. And then just do some calculating. Negative 2 squared is 4. I'm going to subtract 4 over here. So I get y plus 4 squared equals 5. Rather than multiply out y plus 4 squared, I'm just going to take the square root of both sides. So I get y plus 4 equals plus or minus root 5. And when I subtract 4, I get y equals negative 4 plus or minus root 5. I'm going to leave it like this. This is called an exact answer because I haven't rounded off any decimals. And then I'm going to look at my graph and see if this makes sense. So the y-intercept is at negative 4 plus or minus root 5. Okay, 1, 2, 3. Here's negative 4 plus root 5. Root 5 is approximately 2.4, would be up 2 and a little bit more. Negative 4 minus root 5 would be down 2 and a little bit more. So that makes sense. These are the y-intercepts. Now let's talk about general form. So we have standard form. To convert to general form, review what general form looks like here. We have an x squared and a y squared term. Then we have two linear terms, one for x, one for y. And then we have a constant. To convert this equation into general form, all I have to do is multiply this out. Keep in mind, x minus 2 squared means x minus 2 times itself, so you're going to get 3 terms. I'm going to go ahead and multiply these out and then arrange the equation so it's in general form. X minus 2 squared is x squared minus 4x plus 4. Y plus 4 squared is y squared plus 8y plus 16. According to general form, the squared terms need to be first in alphabetical order, then the linear terms, and then the constant has to be equal to 0. X squared comes first, then y squared, it's a plus sign, then the x term, then the y term. And now I'm going to combine the 4 and the 16 to make 20. Subtract over 9. 20 minus 9 is 11. And here is general form of this equation. Try that one more time. Convert this equation into general form. I encourage you to pause the video, convert the equation, and then resume the video to see how you did. Remember, when you multiply out x minus 3, quantity squared, you will get 3 terms. When you multiply out y plus 5, quantity squared, you will get 3 terms. And now I just arrange this so it's in the proper order. The two squared terms come first, then the linear terms, and then the constants. 9 plus 25 minus 9 is 25. There's general form. We're going to practice a few more examples. The next one, we're given our equation for the circle in general form, and we want to find the center and the radius and any intercepts of this graph. In order to see the center and the radius, this needs to be in standard form with the x minus h squared and y minus k squared. What that means is you're going to have to complete the square. So I'm going to rearrange this. It's kind of like working backwards from the example we just did. X squared minus 6x, and then I want to complete the square so that I can factor it. Y squared plus 10y, complete the square. And I'm going to subtract 18 over to this side, because I'm keeping in mind the end goal. The end goal is standard form, where I have a perfect square plus another perfect square equal to a radius squared. I'm completing the square so that I can factor this into a perfect square. I'm completing the square here so I can factor this into a perfect square. Remember, whatever you add to this side of the equation, you're also going to have to add to this side. To complete the square, you take the b value, divide by 2, and square it. Half of 6 is 3, squared is 9. Half of 10 is 5, squared is 25. Whatever I add to this side of the equation, I also have to add to this side of the equation. We completed the square so that this would be a perfect square. I can factor it, factor this one, combine like terms, and now the center of the circle is positive 3, negative 5. And the radius, remember you have to square root the 16, is 4. All right, we are going to calculate some x and y intercepts. For an x-intercept, you just let y equal 0. So I'm going to substitute 0 into, I'm going to use this form because it's easier. Five squared is 25. When you subtract over 25, you get negative 9. And at this point, if you go to take the square root of both sides, you cannot take the square root of negative 9. So this means there are no x-intercepts. All right, let's try for y-intercepts. We're going to let x equal 0. Negative 3 squared is 9. Subtract over 9. And I get y plus 5 squared equals 7. Take the square root of both sides. Y plus 5 equals plus or minus root 7. And finish solving for y, subtract 5. So my y-intercepts are at 0, comma, negative 5 plus or minus root 7. All right, next one. We're going to find the center and radius of this circle. So first I'm going to rearrange this so that I can set it up to complete the square. 2x squared plus 12x, fill in the blank, plus 2y squared minus 2y, and I'm going to add 3 over to the other side. This time, when I'm completing the square, I have 2x squared instead of 1x squared. So what I have to do first, before I figure out what I'm going to complete the square with, is I need to factor 2 out of both of these terms. Then I can complete the square. I'm going to do the same thing over here. I need it to be 1y squared. So I'm going to factor out a 2. And whatever I add to this side, I have to add to this side. All right, 6 divided by 2 is 3, squared is 9. 1 divided by 2 is 1/2, squared is 1/4. But I don't put in 9 1/4 here because this 9 in the end needs to be multiplied by the 2. Remember, we factored out the 2, so technically I added 18 to this side. 2 times 9 is 18. Same thing here with the 1/4. I have to multiply that by 2. I didn't just add 1/4, I added 1/4 times 2, which is 1/2. You can use decimals if you want. So when I factor this, x plus 3 squared, y minus 1/2 squared, or 0.5. And then when I add this, I get 21.5, which I'm going to write as an improper fraction. So let's see, 43 halves. Again, if you want to use decimals, that's fine. All right, keep in mind, standard form of a circle looks like this. The coefficient on each perfect square is 1. Right now, I have a 2. Well, here and here. So I'm going to divide everything by 2. 2's cancel out. X plus 3 squared. 2's cancel out. Y minus 1/2 squared. And here, 43 halves divided by 2. This is the type of thing you should be able to do without a calculator. It's just 43/4. We were trying to find the center and radius. Now you can see the center and radius. The center is -3, positive 1/2. And the radius is the square root of 43/4. Remember, when you take the square root of a fraction, you can treat the numerator and denominator separately. So I can simplify this and write it as, root 43 over 2. There's the radius. Last 3. Write equations in standard form, not general form, standard form for each of these circles. For the first circle, we know what the center is, so we have H and K. I'm going to go ahead and put that into my equation. And now I need a radius. One thing you can do is sketch it so you can kind of see where you're coming from. -2, 1, 2, 3, 4. There's the center of the circle. And the circle passes through the point 7, -1. 1, 2, 3, 4, 5, 6, 7, -1. So from the center to this point, this is the radius. In order to find the distance between 2 points, you're going to need the distance formula. Or you can picture this as a right triangle and use Pythagorean theorem. Basically the same thing. The distance formula says y2 minus y1. I need to use subscripts. y2 minus y1 squared plus x2 minus x1 squared. So if I apply that to my 2 points here, 4 minus -1 is 5. -2 minus 7 is -9. So I get the square root of 5 squared plus -9 squared. That is 106. Now keep in mind that's radius. In my equation, I want radius squared. So when you square square root of 106, you just get 106. Next one. This circle has endpoints of a diameter 1, 4, and negative 3, 2. So again, I'm going to draw a little sketch just so I can see what we've got here. 1, 4, 1, 2, 3, 4. Negative 3, 2. 1, 2, 3, 2. This is the diameter of the circle. So that means in here is the center. So what I'm going to do first is use the midpoint formula to find the center. The midpoint formula is basically just averaging the x values and averaging the y values. So negative 3 plus 1 divided by 2, and 2 plus 4 divided by 2. So my center is going to be at negative 1, 3. I'm going to put that into my equation. And now I need to calculate the radius. You've got a couple of options here. You could use the distance formula to get the length of the diameter and then divide by 2. Or you could use the distance formula to find the distance from the center, negative 1, 3, to one of these other 2 points. I'm going to use the distance formula to find the center, from the center to this point here. All right, distance equals. So this point is negative 1, 3. y2 minus y1. 4 minus 3 is 1. x2 minus x1. So this will be 1 minus negative 1, which is 2. So I've got 1 plus 4 is 5. This is my radius, root 5. When I put it in the equation, I have to do root 5 squared, which becomes 5. Last one. We're going to write an equation for a circle with center, negative 5, 6, and it's tangent to the y-axis. First of all, I already have the center, so I'm just going to put that in my equation. And now I have to come up with the radius. Remember what tangent to means. It means that the radius intersects the y-axis at a right angle. So the distance from the center to the y-axis will be my radius. I'm going to sketch a picture here. Negative 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Negative 5, 6 is right here. Tangent to the y-axis, so here's the y-axis, means this circle touches the y-axis right here. So from here to here is the radius. The distance from the y-axis to the center is 5. When I put that in my equation, I have to square it. 25. The assignment is posted on Google Classroom, and I'm going to have you turn in the notes after you have watched the video and filled them out.